All right, mathletes number 3. So here we're given the graph that shows a position function of an object moving on a straight line. What I realized when I was working on preparing for this question is that I needed to give you some space below the x-axis here. So let me show you what it'll be like more on the test. And what I should have given you here on the practice test is just a little space below so you can graph below the line. So anyway, the first, and you'll see that more on part B, but the first part, part A, says use the graph of the position to determine the time intervals when the velocity is positive, negative, or zero. Okay, so I'm just going to go through here. Remember that the velocity function, v of t, is the derivative of the position function, right? So this is very similar to the last test in quiz, or quiz 4, when we had to graph the derivative of a function given another function, right? This one's a little different though, because we have some of these kind of like sharp points, right? And we have this place where it's horizontal, but it's the same idea, right? We want to plot points on the, I'll use green here for the velocity function, or actually I'll just use pink since I have it right here, okay? So for the velocity function, I'm going to find these 0 points. So I have a 0 point here, right, where we have a valley. I have a 0 point here where we have a peak. And then I also have 0 points all along that stretch, right? So I'm just going to actually just kind of draw zeros all the way there, okay? So that's the first thing. I'm going to find the zeros, okay? I don't know, that's just my method where I start. So now everywhere else is going to be positive or negative, right? If those are the 0 points, it's going to be positive or negative everywhere else. So on this side of 0 over here, we actually have a couple things, right? Because here it's not 0, but it's neither positive nor negative. So that's a point where the derivative is undefined, right? When we have a sharp point right there. So so on the left side of this, this slope is positive, right? And not only positive, but it's constant, right? It's going up 2 over 1. And so the slope is 2. So it's actually going to be positive 2 at that point, right? So I'm just going to graph it since I figured that out. And so I know it's going to be positive on this side, right? And it's going to be positive 2. So I'm going to put an open circle here and an open circle there, because those are points that the derivative is undefined. Okay, then from here to here, the slope is negative, right? So it's going down. So it's negative. Okay, from here to here in this stretch here, the slope is positive, right? It's going up and to the right. So over here it's positive. Here we already talked about it, 0. Between here and here, the graph is positive. And then on the other side of this 0 here, the graph is negative, right? So it's going to be negative. All right, so let me try to get those intervals written out here. So we'll start with positive. So positive, the intervals where it's positive is 0 to 2. Okay, from here to here it's positive, right? Then it's positive from here to here. So that's 3 to 5. This is interval notation, right? Okay. Then it's positive again here from 9 to 10. Oops. All right. And then negative, it's negative from 2 to 3. And then also from 10 to 12. Okay, that's where it's negative. All right, and then it's 0 at 3, at 10. So those are just individual points. So I'm just going to put them. So no parentheses there. And then also I'll just separate them by semicolons. And then also there is an interval 0 where it's from 5 to 9. Okay. All right. So that's where it's positive, negative, or 0. So now we want to sketch the graph of the velocity function. All right. So I already started here. We have a constant slope of 2. Now here it's negative, here it's 0, here it's positive. So I'm just going to go from starting somewhere at 2, it's going to go from negative to positive, right? Something like that. So it doesn't have to look exactly like that, but that's the idea, right? And then you have open circles at the end there. Okay. Actually, I'm sorry. I need to go all the way to here, right? It's positive from here to here. So let me start again. So I'm going to go negative to positive like that. Oops, and I missed I need to go through 0 here. There we go. All right. So make sure you go through that 0, and then make sure it's negative on this side, positive on this side, right? Okay. All right, and then from here we know it's 0 all that way. I'm just going to put open circles on the end because remember at these sharp points, it's the derivative is undefined. All right, and then here we go from positive to negative, right? And so that's going to start up here somewhere, and it's going to go down here somewhere, right? Okay. And remember that a couple things. These the derivative doesn't have to connect. In fact, it won't connect, right? Like at these sharp points, part of the reason why it's undefined at those points is because the slope on one side is not the same as the slope on the other side. Remember, the definition of the derivative is a limit. So if the limit from the left doesn't equal the limit from the right, then it's undefined or does not exist, right? And so that's why the derivative doesn't exist or is undefined at those points. But since the slopes are not the same, you're going to have these discontinuities here, right? Where the jump discontinuities where on one side of the graph, the slope is way different from the other side of the graph, right? So anyway, so that's what the velocity function looks like. So v of t, right? And we'll just label this here v of t. Okay. So next we're going to do the same thing for part C with acceleration. All right. So remember that acceleration is the derivative of velocity, also known as the second derivative of position, right? So I'm going to do the same thing. So where is acceleration positive, negative, or 0? Okay, so I'm looking at the slope of velocity, right? The slope of the pink line. So I'm ignoring the blue line now. So acceleration is 0 in this spot, right? From here to here, acceleration would be 0. Here, acceleration is positive, right? In that whole interval from 2 to 5, it's positive. Here it's 0 again, right? Okay, so I'm just gonna trace over that line there at 0, and then here we have negative, right? Okay, so we have positive in that spot, negative here, and then we have a couple intervals where it's 0, right? So let me write this out. Positive is from this interval from 2 to 5. Okay, and that's it. And then it's negative in this interval here from 9 to 12. Okay, and then we have a couple intervals where we have where the acceleration is 0 from 1 to 2, or excuse me, 0 to 2, and then from 5 to 9. And notice how all of these interval notations on this page so far, we're using parentheses, right? No brackets, because none of these endpoints are included. And this is kind of by nature too, because at these points, even at the points where where we don't have those sharp discontinuities, but those are where the velocity is 0, right? And so if it's 0, it's neither positive nor negative. So these endpoints are not included. All right, so that's where it's positive, negative, or 0. So now let's graph the rest of the acceleration function, a of t. So we have these zeros graphed, right? We'll just put open circles on the end of those. All right, and then here we have a positive slope. It looks like it's up 2 over 1, right? So it's another slope of 2 from here to here. That just happens to be the way I graphed it, right? But yours doesn't have to be exactly the same. All right, and then here it looks like it's down 3 over 1. So we'll just call it -3. So from here to here, looks like we have a constant slope of -3. So that's what the acceleration function looks like when we graph it. All right, so now part E. So now it says determine the intervals when the object is speeding up or slowing down. So okay, so speeding up. Now you could do this a lot of different ways. You kind of use these intervals and think about where the signs are the same or different. But I like to look at the velocity function. So if I go back to this pink line here, speeding up is where the velocity goes away from 0. Okay. So, and I'll write this down in a minute, but remember that speed is the absolute value of velocity. So when it goes away from 0, the absolute value will increase, right? If it goes towards 0, the absolute value will decrease. All right. So like in a place like this, it's neither going towards 0 nor away from 0. So this is actually neither speeding up nor slowing down. And it doesn't say to say neither, so you don't have to put those in there. Just leave those out. Okay, so this is neither. And then here, I'm going towards 0, right? As I go from left to right, this line is going towards 0. So it's actually slowing down from 2 to 3, okay? So from 2 to 3, it's slowing down. And then from 3 to 5, it's speeding up, right? It's going away from 0, so that that speed is going to be increasing. So 3 to 5 is speeding up. Here it's neutral, right? It's neither speeding up nor slowing down. And then here it's going towards 0 from 9 to 10. So that would be slowing down, right? Because it's going towards 0. Then after 10, it goes away from 0, right? Even though it's in the negative direction, it's going away from 0, so that means it's speeding up. So from 10 to 12. All right, so those are the intervals. And you can match that up here, like just to give you a real quick example. So remember, anywhere where it's 0, it's neither speeding up nor slowing down. So 0 to 2 doesn't count for speeding up or slowing down. But from 2 to 5, the acceleration is positive. But from 2 to 3, the velocity is negative, right? So where the from 2 to 3, the velocity is negative, acceleration is positive, so that means slowing down, right? Signs are different. Then from 3 to 5, you have positive velocity and positive acceleration, right? So from 3 to 5, the signs are the same, so it's speeding up, right? So you can look at it that way as well. But for me, the graph makes a little more sense. If it's going away from 0, speeding up. If it's going towards 0, it's slowing down. Okay. All right. So that's that. Yeah, be ready for something like that on the test. And let me know if you have any questions about it.